Hello and welcome to the first video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss the nature of physics. So, what is physics? The key idea behind the study of physics is that we can describe and understand the natural phenomena around us. Think about the ancient humans who tried and succeeded in controlling fire, who created the first tools to be able to move heavy objects and to protect themselves from predators. Even these early humans used physics in its broadest sense. But when we think about physics, we usually don't think about ancient people. Rather, you might think about some famous physicists, such as Newton or Einstein, whose discoveries created entirely new fields of physics. You also might think about the way people used physics to predict natural phenomena such as solar eclipses, or to discover entirely new unknown objects such as black holes. Or you might just imagine a blackboard full of complicated equations. All of these are surely manifestations of the same underlying idea: to understand and control the world around us. If we had to define physics, we might say that it is the study of the natural world and its parts, matter and its movement through space and time, and energy. The word physics itself comes from the Greek word physos, which means nature. It then evolved into the Latin word physica, which means the study of nature. Nowadays, physics covers a very broad array of natural phenomena, from classical physics dealing with mechanics, optics, and electricity, to modern physics dealing with quantum effects and relativity. But all of these fields are interconnected, and to be able to understand the modern physics, that is the cornerstone of our current technologies, we have to get a deep understanding of classical physics. Besides just studying how nature works, physics helps us build new tools for our new environments and goals, such as airplanes or nuclear power plants. We could say that physics is related to natural phenomena in three fundamental ways. First, understanding and explaining natural phenomena through the development of laws and theories. For example, we can explain the fall of an apple from a tree and the movement of planets using the same physical laws. Second, physics helps us predict natural phenomena and their future results. For example, we can predict when the next solar eclipse will be. And third, we can utilize our understanding of natural phenomena in making modern applications, such as spaceships or power plants. Here, physics and engineering need to work together. Now, what is the relation of physics to the other sciences? For more than 2000 years, physics, chemistry, biology, and even certain branches of mathematics were not treated as separate fields of study, but as parts of the same thing: natural philosophy. During the scientific revolution in the 17th century, these sciences became separated, but still very closely linked. Physics can be thought of as the basic science because it studies nature in general, and it provides the basis for all the other sciences. It also manufactures measuring devices and invents technical applications that benefit these other sciences as well. As a concrete example, think about quantum physics. The laws discovered by Heisenberg, Schrödinger, and the other famous quantum physicists are used nowadays to create quantum computers, for example. Or they are used in the quantum description of chemistry and sometimes even biology. So one big physical discovery opened new branches of study in the other disciplines as well. What is the relation of physics to math? Physics is very closely related to mathematics. We could describe their relation as mathematics is the language of physics, used to accurately express its description and the interpretation of natural phenomena. There are two very important ways in which mathematics supports physics. The first is that physics uses mathematical equations to express the relation between quantities. Look at this equation, for example. F equals m times a. This is Newton's second law of motion. It describes the relation between the force acting on a body, the mass of the body, and the resulting acceleration. This law gives us a fundamental truth between these three quantities. Different people can measure different forces or accelerations of a body, or even different masses, but the relation between them will always be this. Second, physics uses graphs to show measured data and the relation between quantities. If you conduct a physical experiment, you could either show your results in a table or in a graph. The graph gives a very easy visual for everybody to describe what is happening in the physical system that you study. It also gives an easy comparison with the results of other people's measurements. With these ways, graphs make it possible for physicists to easily communicate their results with each other. Thank you for your attention and see you in the next video.